Welcome to Tech Bytes in News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating project, a dynamic 1.58-bit quantization of the DeepSeek R1 large language model. It's a game changer, folks. Seriously.
Wow, 1.58-bit quantization? That sounds incredibly aggressive. How did they even manage that without completely destroying the model's performance?
That's the million-dollar question, isn't it? They achieved an 80% reduction in model size, going from 720 gigabytes down to a surprisingly manageable 131 gigabytes. The key is their dynamic quantization technique. They didn't just uniformly quantize everything to 1.58 bits. No.
So it's not a uniform quantization? What's the secret sauce then?
Precisely. They cleverly leveraged DeepSeek R1's architecture. They identified specific layers, primarily the mixture of experts, MO, layers, that could tolerate lower bit precision, while leaving other crucial parts, like the down projection matrices, at higher bit depths. It's a nuanced approach. Brilliant, really.
I see. So they essentially tailored the quantization to the model's structure. That makes sense. But how did they determine which layers could handle lower precision?
They combined several techniques. Their own 4-bit dynamic quantization method, insights from the 1.58-bit LLM's paper, Llama.cpp's 1.5-bit quantization, and the superweights paper. They even used an importance matrix to calibrate the quantization process for even finer control. It's a beautiful symphony of techniques.
Impressive. And what about the performance? Did this aggressive quantization significantly impact the model's capabilities?
Surprisingly, no. They tested it using a rather unusual benchmark, generating a Flappy Bird game. Their 1.58-bit version scored remarkably well, achieving 69.2% accuracy on their custom criteria, compared to 91.7% for the 2-bit version. Not bad at all.
A Flappy Bird benchmark? That's unique. But the results are impressive, especially considering the massive size reduction. What about inference speed?
On a 2xh 180 gigabyte setup, they achieved around 140 tokens per second for throughput and 14 tokens/s for single-user inference. Even on a CPU with just 20 gigabytes of RAM, it works, though slower. Amazing! They've made this powerful model accessible to a much wider audience.
This is truly remarkable. The fact that they've made this available as open source is also a huge plus. It opens up a lot of possibilities for further research and development. I'm excited to see what the community does with this.
Absolutely. And they've made it easy to run, too. They provide clear instructions for using Llama.cpp, Ollama, and even VLLM. They even addressed potential issues with chat templates and token mappings. They thought of everything.
It's clear a lot of thought and effort went into this project. This is a significant contribution to the field of large language model optimization. Fantastic work.
Indeed. It's a testament to the power of creative engineering and open collaboration. So, listeners, if you're interested in running DeepSeek R1, check out the links in the show notes. And don't forget to give them a star on GitHub. Thanks for tuning in to Tech Bytes in News. Have a great day.
Bye-bye.